RHS Pre-Calculus presents Pythagorean Identities by
Haley,
Lindsay,
Sam, and Brian. The identities are sine squared theta plus cosine squared theta equals 1, 1 plus tan squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta.
our goal is to show where these identities came from and explain how to apply them in math.
Shouldn't we start with the basics?
Oh yes, first we start with the unit circle.
Right, remember Lindsay, how from the unit circle we get sine theta equals y over r?
Yeah, and you also get cosine theta equals x over r. And finally, you get tangent theta equals y over x.
So why do I need these?
Well, we use them with the Pythagorean theorem. That is, x squared plus y squared equals r squared.
Right, we use the Pythagorean theorem to derive the identities.
Why do we need to do that?
Well, you start with the Pythagorean theorem, x squared plus y squared equals r squared, and you divide everything by r squared. This simplifies to be cosine squared theta plus sine squared theta equals 1.
How does x squared over r squared equal cosine squared theta and y squared over r squared theta equals sine squared theta?
Well, remember how x over r equals cosine theta? Well, x squared plus r squared equals cosine squared theta. It's the same thing. All that was done was x over r was multiplied by x over r, which becomes x squared over r squared. Since x over r equals cosine theta, then it's like cosine theta times cosine theta equals cosine squared theta.
Well, how do you get the other identities?
Good question. First we start with the first identity we just proved. Then you divide everything by cosine squared theta. This simplifies into 1 plus tan squared theta equals secant squared theta.
To get the third identity, you take cosine squared theta plus sine squared theta equals 1, and divide everything by sine squared theta. This simplifies to be cotangent squared theta plus 1 squared plus 1 equals cosecant squared theta.
Okay, I get it. From the Pythagorean theorem, you can derive sine squared theta plus cosine squared theta equals 1. And from that, you get the other two identities. Tan squared theta plus 1 equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta.
Yes, that's it.
Okay, so when do we actually use these?
Well, we will show you how to apply them.
Let's start with the problem. How about sine theta cosine squared theta minus sine theta? Simplify it.
Okay, well, what do I do first?
So first, you start by factoring out sine theta and dividing by negative 1, giving sine theta times quantity cosine squared theta minus 1 over negative 1. This will then be simplified by changing the signs, giving negative sine theta times quantity negative cosine squared theta plus 1. To make this one of our Pythagorean identities, we switch the 1 and cosine squared theta, giving negative sine theta times quantity 1 minus cosine squared theta. Because of our identities, we know 1 minus cosine squared theta equals sine squared theta. So we substitute sine squared theta in. Leaving negative sine theta times quantity sine squared theta. And finally, we multiply, giving us negative sine cubed theta.
I think I understand Pythagorean identities. Thanks, guys.
The end.
Yeah.